Okay, it's been pretty long overview of selenium in ruminant. So I have a very few slides to more or less a summary and also what is the molecule look like and how it is developed. Okay, let me see. Okay, so lots of part already seen, stress and oxidative stress that Peter already said, and the importance of selenium for dairy cows. Also, I don't need to cover anymore. Selenium sources, yes, also covered. So I'll more be emphasized with new molecule, which is Selisseo. It's a selenium and developed by Adisseo. So it's a Selisseo, it's a compilation of the word. It's a commercial name of the product for dairy cow. And here is the main traces that Peter already covered very well, so I don't waste time anymore. So I see a simple summary is the mitochondria of the cell that produce free radicals called reactive oxygen species, and you need the antioxidant to balance up, to remove the free radicals. And there is the important part of the all stories, antioxidants to remove oxidative stress. And there's a big loss of mastitis. Say this is UK publications. Per cow you lost 290 euros if you have the cow have a mastitis. And here's how it works. The selenium, mostly they work through this, the major enzymes. We say 25 selenoproteins, and this selenoproteins has a key part as selenocysteine. So selenocysteine, which is this molecule, here is the selenium. So without effective selenium sources, you don't have enough selenoproteins in the body. And hear more about the optimum selenium for stress that I do not. Here's another summary. If you use organic selenium, they have a better rumen incorporation of organic selenium, which is selenium methionine, into microbial protein into the blood. So microbials use selenium methionine to form microbial proteins that can integrate into the body system. While selenite, there are a number of papers saying that selenite can be precipitated by microorganisms into elemental selenium, or they become precipitation. So you have a poor absorptions here. Already have a number of publications, you can find it. And actually, I sent off some of the papers already here. There are lots of studies about this one. And here is another paper showing that the sulfate and selenium, they compete with each other in dairy cows. When you have a higher level of sulfur, because sulfur and selenium, they are twin. So the body cannot differentiate. So high sulfur will influence selenium absorption if it's selenite. But if selenium methionine is different, selenium methionine goes through different channel of absorptions. And here you have seen this one from Peter, that you use selenite. This is selenium in the blood. Here is selenium methionine. You get a much higher absorptions. Okay. Here's a short summary of the comparison. Selenite and organic selenium, you have a much better absorption, less excretion. And also in the 3.3% incorporated in rumen microorganism, well, here is 23%. Okay, fecal excretion, and microbials use selenium methionine to form microbial protein, so you get a less fecal excretion. And for only 3.2% of supplemental selenium being transformed into milk, well, here's 16.3% into milk. So milk has a higher transformation, and then more selenoproteins in the body and a better antioxidant status. So overall, it is very clear that organic selenium sources is much more superior compared to selenite. Yeah. And this one, so come to this organic selenium. Organic selenium, you have a couple of choices. many people use yeast. Okay, yeast was a very good one. For 10 years, the yeast was very effective because they supply very good amount of selenium-methionine. We, in the last few years, collected more than 100 samples of all different brands of yeast products. We find that many brands have a relatively stable, around the 60% of selenium and selenium-methionine. But there are some brands with highly variable in terms of selenium-methionine. We find only 15% or 58% is very, very variable in terms of selenium-methionine content. And there are up to 50 different molecules that is identified from beyond the selenium-methionine, but all have to be broken down to selenite. So the rest selenium are up to 50 different molecules, and most molecules are either harmful or not being utilized by the body. They are being, a paper published in 2012 here. Well, because these are yeast fermentation products, they are much more effective than selenite. But however, the difficulty was selenium-methionine is highly variable, and the product is dusty and even caken, and then some of them carry impurities. And then it was common, people know that some of them contain heavy metals in the product. Well, the new molecule is it's a Selisseo. The molecule is a chemical synthesized. It's a pure molecule. Hydroxyselenium-methionine is a pure molecule, like we produce methionine. Adisseo is quite well known for methionine production, but the same molecule, but selenium to replace sulfur. So we get a pure molecule. It's 99.5% of the content, all the batches. Okay, so that's the advantage. We call this third generation. And here is how it was produced. This is selenium, and selenium replaced this molecule is a hydroxymethionine. Hydroxymethionine here is a sulfur, but we use selenium to replace sulfur. We get a new molecule, which is hydroxyselenium-methionine. And this is purely new, not existed before. So we had to go through all this process of registration in European Union and all the countries for registration because this molecule did not exist before. And then, so this is hydroxyselenium-methionine. This is we started in 2009 from 400 milligram of this molecule. So developed through a number of years in process and so on. We got 4 patents of this product and a full EU registration. So that developed this molecule, and then it's actually selenium-methionine source in the body, and then convert into selenocysteines in the body. So, and this molecule is a good one because it's a pure. When you analyze by HPLC, it's only one peak. So very easy to analyze, no impurities. And the molecule is hydroxyselenium-methionine, and it's one peak, and the rest is carrier. It's carrier like silica, 95%, and 5% is this molecule. Within this 5% there is a 40% is selenium. So that's 2% is selenium. Okay, it's a purely molecule. And then we have done quite a number of studies in dairy cow because we have to go through the EU registration. So it was very comprehensive studies. We compare selenite and Selisseo. So selenium in the milk, we get many times, 2.5 times more selenium in the milk with Selisseo in comparison with selenite at 0.3 ppm. And this one was published in 2011. And we also have 3 different levels. Say this is sodium selenite. This is Selisseo 0.1, 0.3, and 0.5. Total selenium in the blood. You see the linear increase. So meaning that I have a really higher increase. You see, compare this 0.3 sodium selenite, and this is much higher here in the blood system. And here, absorption of organic selenium sources plants increase of selenium concentration in plasma. So in terms of selenium, yeast and also Selisseo organic forces, you get a linear increase, okay, in selenium. So more selenium in the plasma, you get a better antioxidants in the body. Here is a publication by Reading University. You get a more selenium in the blood. You have a higher antioxidant activity with a glutathione peroxidase enzyme. and improves antioxidant status overall. This is total antioxidant status. Here is selenite, here is siliceo, and also here is the MDA content. The lower the better. So here is the lowest one. And here's the product, 2% of siliceo, and with EU registration 3B814. This one we got the registration 2013 in EU registration. We have two forms, which is 2% selenium in the form of hydroxyselenium, and also with 0.1% diluted one, because this one is very concentrated, only 10 grams per ton feed. It's very difficult to handle, so we diluted that into 0.1, so therefore the feed mills can use it. And in third one, we have a liquid one. This is also 2% selenium, but in the liquid form, it's clear solution because the molecule is water soluble. This is the only water soluble product in the market because the yeast there is not water soluble. And so this is the molecule, hydroxyselenium. The selenium 79 gram equals 40% of the molecule, and so total selenium is 2%. You use is 5% of this molecule in the overall product. The other 95% is like silica. It's a very good flowability, no dust at all. So well, the yeast products is very fine powder, and then in many cases it get dusty and caken. But this one, because it looks like vitamin E, okay, because the silica, very high quality silica as a carrier. So you use 10 to 15 grams per ton feed treatment. Okay, this is for so it's a very small amount. Okay, only this is 20 kilogram in package, but this one is 0.1. So use like 100 to 150 gram per ton feed. And this one is a liquid in the clear solution. So it's a 4 times 5 liter in a carton box liquid, and here is 0.1%. And the product there is a very stable. We have tested in many conditions, in vitamins, in aqua feed, in high pelleting temperature. We get a very good recovery. So the molecule is very, very stable. There is another molecule on the market. It was a pure selenium methionine, but it's not very stable. It's very easy to oxidize. But this one, the advantage is stability is good. So we get compare the selenium methionine, the molecule is full recovery, while siliceo has a much higher recovery in a very aggressive conditions, 40 degree and 75 relative temperature in open bags. So this one has much higher recovery. And also this one has a very nice distribution of the particles. So you don't see any dust at all in the product. And then because the distribution of here is right in the right range of the particles. Yeah. So it combines all the good things of the selenium product. It's 100% efficient, and it's a pure product, pure molecule, no impurities, and this is a very reliable product. So you have the product, you know it's 100%. So you don't worry about the impurities. You don't even need to bother with HPLC check. But check is very easy to check HPLC, and it's very stable molecule and very safe to use. We have tested in broiler birds at 10 ppm in broiler. We did not see any toxicity signs. So meaning this is very different from sodium selenite, that 1 ppm you will see toxicity. But this one, 10 ppm, there's no problem with toxicity. But so we did not test beyond 10 ppm, okay, because EU registration that requires you have to look at toxicology, okay. So it's a very good source of we call it a new generation or third generation of selenium supplement. And then this is EU registration, okay, EU registration number, and then the product they received the big award in France in 2014, I guess, 2014, as the only feed additive received the award, this one. So we think that's the new generation of organic selenium for dairy cows. Thank you very much.